All right, welcome everyone to our September webinar. Can you go back a couple of slides, Al? All right, welcome everyone to our September webinar on managing cloud and container environments with Tidal. Devin Heads and Alistair Davidson are going to lead us today. Al, are we doing all right?
Yeah, fine.
Okay. All right. So, Al and Alistair and Devin, excuse me, are going to be leading us today. We'll start with an overview of Tidal for clouds and containers, and then they'll provide use case demonstrations covering AWS and S3, Kubernetes, and Azure. Then I'll spend a few minutes on some of the Tidal news, and we'll move into Q&A. So, speaking of Q&A, a few pieces of housekeeping before we begin. All participants will be in listen-only mode. We will record the session and post it to the customer portal early next week for viewing. And lastly, you can submit questions using the WebEx Q&A panel on the right side of the screen, and we'll answer as many as possible at the end and post answers on our portal. So now I'm going to turn it over to Al. Al?
And actually, speaking on Al's behalf, this is Tom O'Rourke, so I'm going to just do a brief setup. So, based on what we saw yesterday, we have an audience here, a lot of people who are very familiar with Tidal, but cloud and containers may be one of the things that you've just begun to work with, or you're looking for a broader viewpoint. So let me start by just saying that as with all of the things that we look to automate with Tidal, we believe that what Tidal does is it provides significant advantages over the native schedulers that are built into products from mainframe batch scheduling and cron all the way through to the embedded schedulers in the cloud, the embedded schedulers in container management systems like Kubernetes. These bullets here should not be a surprise for all of you. You've probably had these discussions about these items with your management or with application teams who don't understand why they should use Tidal. So it's just really a reminder that workload automation has a big advantage over the native schedulers and the islands of automation that they create. Next slide, Al. So in context, what we're going to be talking about today really take us down into the adapter and agent integrations from Tidal, going into the areas of IT command and control and infrastructure management. How do you go and make the servers and the storage elements fit within the steps in a process, and then at the infrastructure management level, how you have the ability to be able to spin up resources, run them, and turn them back down again. And over the context of the discussion, we're going to be talking about the environments in which these enterprise processes run in, what Tidal runs, starting with the physical hardware distributed in mainframe and taking the world out to containers. So if we look at the context of scheduling today, we've really moved from batch jobs to all the way to container orchestration. We've taken the journey from automation managing the physical infrastructure to automation managing the logical infrastructure. And as most of you are aware, this isn't a transition that has left the physical infrastructure behind. Almost all Tidal customers are, have their automation teams handling both the physical and the logical. And the new players in this are being able to manage cloud servers and storage and networks, being able to go and address the containerized elements of this, whether they're in the cloud or they're in your own premise area. And from a workload automation perspective, the core considerations have always been around making sure that the tasks succeed, coordinating between tasks. This is dependency management, handling the data sharing that needs to happen between the steps in the process, making sure the systems run efficiently, making sure that there is isolation between processes, because there's always multiple processes that are going on at one time, and handling security. But the logical infrastructure brings in some other things. It means that we need to think about more and more with cloud about how do we do cross-site coordination? How do we do cross-site data sharing? And because of the way that cloud and container resources are there, making sure that we can efficiently use dynamic objects. So today, we're going to dive down into cloud and containers. We're going to do Kubernetes. And I'll say that, Kubernetes brings a lot of additional items in to be able to go and think about. But at the core, there are a few concepts that you really need to understand. A Kubernetes cluster is the way that you pull together the resources from multiple machines in order to create a virtualized farm of resources to run your applications. Nodes are the worker machines that sit inside of the clusters, and then pods are the elements inside of those nodes to be able to go and to use for management. You have the containers themselves that sit inside of the pods. Those are the equivalent of your virtual machines in the virtual world, or the physical machines back in the physical world. And then, as Devin and Al are going to talk about today, those containers, since they are really logical servers, they may even include a Tidal agent, and that Tidal agent has the capability to self-register. That's a feature we brought to Tidal in the last year to make it easier for dealing with these server instances that come and go. Kubernetes also has this idea of a control plane, and the control plane is really its interface for managing the cluster. The core element to understand there is that Kubernetes has its own scheduling element, and Tidal, through the Kubernetes adapter, manages these elements by working through the scheduler and working through the APIs of the cluster in order to be able to go and manage all of these elements. And if you want to learn more about Kubernetes, I've included a link here to go and drill down into all of that. So to set up the discussion that we're going to have here today, Al and Devin are going to take you through some use cases that they've built around an inventory processing set of activities. And what you're going to see as they're moving along is that they've built up a hybrid multi-cloud environment. There's going to be work that's going to start on premise and go through the cloud and go into Kubernetes, touch back on premise, go off to another cloud, and then come back on premise. And with all of that in place, as the background on the story, let me turn it back over to Al. And Al, if you want to go and get us started with what we're going to see today in the demo.
Sure, thank you, Tom. Okay, so kind of titled this as Tidal moving your data through time and space. So this isn't in a kind of Star Trek or Doctor Who kind of way. It just reflects the way, as Tom has mentioned already, that processing of data, it can happen both on premise and in the cloud. So the data is going to change. The Tidal will move your data over a period of time. Processes will change that data. And these changes are made over multiple locations by multiple applications. And those applications could be on premise or in the cloud. So the idea is that wherever that change is occurring and on whatever type of applications, we're ready for it. We're ready when it arrives and wherever it arrives. So we can detect things that need to trigger other things, whether they be in the cloud or on premise, whether they're in Amazon storage or on premise storage. And from that, we can move the data around. So we can move it from premise to the cloud, we can process it there, and we can spin up the resources that we need for on-demand storage and compute. So one of the key things here is that we're no longer in an environment where things happen every Friday at 5 o'clock, for example. Things can happen anywhere, anytime, and we need to be ready for that. And not only that, but we need to be able to rapidly spin up the resources that we need for perhaps unpredictable volumes of processing or for unpredictable demands from users who just want to have something happen now and happen, you know, it could be the result of an email, it could be the result of the management requesting some emergency information or resources. So Tidal can handle that. The flexibility is there to do what we need, where we need to do it. And in this way, we're enabling proper hybrid multi-cloud business process automation. So it's the process that we're automating, and we're doing that from the good old Tidal concept of a single point of control. So to kind of illustrate this, what we've got is our Tidal Souvenir Superstore. And we're going to trigger this whole process off when the sales processing data arrives. It's going to produce a file which is on premise. And then, so we need to then say, okay, let's start moving this file around. Let's process the data. Let's process it on site and in the cloud. And so we're going to do that by creating an S3 bucket to store whatever we're processing. And then we're going to start up an existing EC2 cloud instance to process that inventory data and perhaps do some additional sales processing. Once we've got that, of course, the file needs to go to the AWS instance. The process will process the SSH process will process that file, and then we're going to move that file. So it's had its first stage of transition. It'll be moved into that S3 bucket. And finally, we might want to do things like connect to an external vendor's API to do some kind of additional stock request, perhaps, because unfortunately not everybody has Tidal, so we might want to use some more generic method, but still use the Tidal adapters to make contact with external suppliers. And so in brackets there, we can see the range of adapters and Tidal capabilities and functions that we're using. The S3 adapter, the AWS adapter, FTP, SSH. So it's a mix of both the traditional and some of our newer technology. And of course, the extra piece that will come up within Devin's piece will be the whole Kubernetes environment. So let me just move forward to that. And so Devin will explain what happens next after we've done our AWS processing, after we've spun up our temporary resources. We're going to do some further analytics within that Kubernetes environment, and Devin will describe what we're doing there.
Thank you, Alistair. First, I would like to say it's good to see so many old recognizable names. I look forward to working with you guys in the future. So we're going to create some storage on a Kubernetes cluster. Because we're using a database system, we need to have persistent storage, so storage that stays. We're going to be creating a persistent volume claim in Kubernetes. So this is something that allows a pod to connect to the storage. And then the next thing we'll do is we'll create some services. We'll be deploying some pods using deployments and stateful sets. So the two services that we'll be creating is an FTP service and a MySQL server service. A service is something that allows communication between internal and external sources. So we can communicate externally to an individual pod using the service. And then also we can communicate directly to the MySQL pod to pod using the MySQL service. So just a little quick, I think we talked about this previously, but I'll review it real quick. So pods are, we can think of them as containers, although they're not complete containers. It's a container that contains a container, so to speak. It's possible to actually have two containers in a pod, and actually in our scenario, we're actually going to have a pod with two containers. So we have one pod that has a MySQL database instance, and then we have another pod that's going to actually contain FTP service and also an agent. So in order to deploy these pods, we're going to use something called a deployment, where this is a Kubernetes term that is basically an object that works to make sure that pods are in a desired state. And then we're also going to use something called a stateful set. This is for the MySQL Server database, because the database is persistent, right? We don't want to lose data in case the pod goes down. So we have a persistent database, and we're going to use a stateful set for that. And finally, we're going to create an agent, right? So inside that pod, we're going to have an agent, and that agent is going to be a self-registering agent, and you'll see that in the demo. And then, so after we finish creating the pods and services, we need to get some environmental information. You know, we need to know, okay, what are we connecting to? What's the name of some pods? So Tidal is going to query the Kubernetes API and get some data. And then we're going to store that in some variables. And then after we store this information in the variables, we're going to run some jobs. So we have a registered agent now. So now we're going to basically get the files. We're going to load the files from the external source. We're going to create a table. We're going to load data into that table. And then finally, we're going to verify that there's data in the table, and then we'll send that file back to S3. So the really cool thing about this whole process is this is something that's done in seconds or minutes versus, you know, taking hours or days to build physical resources. And we're able to take this whole process, this application, so to speak, and move it to other Kubernetes environment, right? So something that if you had to build this from scratch and you had to go build this on many different servers, it might take you days. We can move it to different environments on and off-prem in a matter of minutes or seconds. So this allows for, you know, creating easy cloud processing. And of course, we could always set up cross-platform dependencies, which is the power of the Tidal system. And after we're done with it, well, of course, you know, we don't need it anymore, so we're just going to remove it. We're going to completely delete it. This creates an on-demand processing, and it saves on resources, and it saves on time. And with that, I will hand it back over to Alistair.
Thank you, Devin, for that explanation. Yeah, so I know you want to get started on this, but just to show you the end of this, what we will do is after Devin's finished his piece, we want to get that data back. We want to clean up what we've done in AWS, and we want to stop our instance. We're finished with those dynamic resources. We'll take the modified stock data, so that file is changed again over space and time, and we're going to move it back to the database server. Having done that, we can also then delete our S3 bucket. And then finally, we can say, let's do something extra. We want to move that stuff as well to an Azure, Azure environment. So what we're going to do is take a copy of all the inventory data for compliance reasons, maybe. We're going to copy that data back to Tidal, and then we're going to put it back into an Azure blob. And then finally, what we might want to do is run Cognos to just give us some reports for management. So it's probably, in many ways, this demo is elaborate in the number of pieces it's using, but it just is designed to show you that wherever you want to do something, wherever that happens in the cloud or on premise, we can handle that. Okay, so let's switch over to demo mode. Okay, let's move this up here. Right, so what we've got, I've kicked off the demo to start with, and this is our imaginary on-premise. So we're imagining that in our Tidal souvenir store, lots of things have been bought during the day. So the first thing that we've done is to extract the stock levels from our on-premise database. So this is just standard stuff. You can see that the output has made use of one of the things that we can do in the JDBC adapter now, which is to store the output into a file. So you can see that our select command has gone into a file. So that means that, we don't have to do variable to transfer that output. We can work with the file if that's what we choose to do. So as a result of that, we've gone and opened a report, and we can get that report output to check what's been happening. So you can see what's hot in the Tidal souvenir store. Some things more than others. Nobody really wants to buy the Rick Kane oven gloves, but Ken Kachinka's autobiography is selling pretty well. So sales are up, stock is low, and the processing will move on to the next stage. So what that has done at this point is to trigger another action. So if we go and take a look at our file events, the arrival of that file has started the events which are going to move processing into our EC2 instances, and then onto, finally after that, onto the associated Kubernetes, where we're going to build stuff up for the analytics idea. So we've got our file there. We've got, of course, in good old Tidal style, we can use our variables to get the file name or to manipulate that file name. And what we've done there is to start our daily update in the cloud and report the stock level. So we've already seen that report. And of course, the other thing that we could have done there is we could have used the same trigger to go and have a look. I've used the alerts here. This could be sent out by email, by reporting, whatever method you want to use to send that report about stock levels to other people. Okay, so we'll move into the business activity here. So you can see here that we've also got this. We're making use of some of the other more recently introduced functionalities, such as the tags. We've tagged this under September webinar to get a business orientated view of the processing. Of course, we could also have done that under our SLA. So let's release this one now. So I've just put it on operator hold so that we can see what's happening. I'm going to release that one now. And we'll start to see that move through the process. So let's just switch to our PERT view. And if we focus on that a bit more, you can see that we're starting to move now through the different steps of this thing. So the first thing that we're doing here is to start our EC2 instance. And if we open that one up, we can see that, again, instead of having to go through Amazon, we've done that centrally. We've managed this startup process through our own Tidal adapter, and it gives us that report on what it's done. And again, because it's done through Tidal, we've got a pretty quick, through that central point of control, we can also see our request there to start up this instance is pending. We've got the opportunity, of course, to override that. We could go in there and stop the instance terminate. So, if Tidal is always able to accommodate those last minute requests, those changes that might take place. So as that instance is starting up, it's going to pass some information. So the transfer of the stock to that instance is waiting for that completion. So it's waiting for the EC2 instance to start up. So rather than hanging around, let's just see what it's going to do. So the output, so right now it's waiting for that connection. So we haven't got a connection yet, so it's timed out. It will try that again. If we look at the override, what we've got is this is our EC2 instance, and this is where it's transferring it to, and we've turned that file name into a variable for the purpose of the transfer. So we can also then, after it's done that process, we can go and see what it's going to do here, which is to run the SSH. So in that EC2 instance, we've got a combination. So we're using both traditional methods and adapter methods to do that processing. So there's nothing to stop us running that SSH job and then running it just as a bash script. So a couple of things that will happen there. I've got, for example, just doing some processing on that file and then using S3 commands to put that up into the bucket. So now you can see it's moving through. we've got our cloud started, we've got our EC2 instance started, we've transferred the data, and we've run the update command there. And so now what we can do is copy that process data. And again, I've just used the bash for this. Of course, if we had an agent, a self-registering agent, which Devin will show you later, we could use all the functionality of a Tidal agent. So right now we're just doing that with the bash script. And we can then go and see that the web service, so this is where we might want to, once we've done our copy up to S3, done the further processing on that EC2 instance, what we may want to do then is simply to run a web service, connect to that external vendor, and just, give them instructions to send us something else. So it's the usual thing that where we don't have the adapter there, we'll use that web service. And finally, what I need to show you on this one is that we have done another event, which is in here. And this one is we want to transition, we want to hand the baton to Devin's part of the demo. So what we've done here is to have a monitor on that Tidal bucket for the data that we uploaded to S3. So we're looking for that key name prefix and that stock update. And we're looking for it in this bucket that we've already created. And when we see that, we're going to trigger the Kubernetes build and process. So if this has worked well, so you can see that that's been triggered here. And so at this point, I'm going to let Devin explain the magic that's going to happen within the Kubernetes container. Over to you, Devin.
All right. Thank you. Let me share my screen. So I've actually already started the Kubernetes job processing. Let me just show real quick. This is our starting environment. Okay, sorry. You guys see me? Let me know when you can see the screen.
Coming up now, yeah. We've just got the command prompt there on your screen.
Okay, so this is our Kubernetes environment, right? And it's basically, I'm showing that this is a blank environment. We don't have any PVCs, we don't have any pods, we don't have any services. So we created, I've already started our Kubernetes jobs, and the first thing we're going to do is create a namespace. And we created some storage. That was our first thing in a storage class. So if I go back into our environment and we look at our namespaces, you'll see we have a Tidal Cloud namespace. So I'm just going to show you, this is an example of a storage class that we created, right? The output from creating the storage class. And this is an example of a Kubernetes job that is going to create the PVC. One of the nice things about the jobs is that we have this YAML here, right, that you can look at and see how we're actually creating these objects. So after we create the storage, we want to go ahead and create the services and the deployment. So I'm going to go ahead and release that job. And then what you're going to see on the Kubernetes side is that we're going to go ahead and create these deployments. We're going to create the pods. We're going to create the services. So remember, we have two pods. One pod has a MySQL Server container. The other pod has the agent, and it also has an FTP container. So when this finishes, we can go into the Kubernetes environment and see what that looks like. So just to look at one of these jobs, we can see the output from this job, which is not showing up. But we can see here, this is the way that we create a service, right? So in Tidal, we have the ability to define a particular type. We selected the service. If we wanted to use YAML, we could click on the YAML option. So that's a nice feature. All right, so you notice here that our services and our pods are created. So we'll just go back here real quick just to show that if we do a get services, we should see our services. And if we do a get pods, we should see the 2 pods that we're using here. And now in the running state. So the next part of this is going to be to get some environmental information. So we need to capture information about, what pods are running and names of pod and some endpoints so that we can communicate to the services, right? So we want to send a file externally or get a file externally, we need to know what the name of that file is. We need to capture that information. So I'll just go ahead and release this job. And this is going to run fairly quickly. It's just going to basically create a bunch of variables, and I'll show you that after it finishes. So it ran quickly. And if we look at our variables, we have this information about agents, pods, all these different pieces of Kubernetes data that we will need and we'll use actually in the other jobs. One thing that I forgot to mention is that we did self-register an agent here. So I'm sorry that was done in the previous job when we created the pod, right? One of the pod has an agent on it and that agent self-registered. It's going to self-register in an agent list, and we're going to use that agent list to run jobs. So let's go back here. The next step is and I'm going to release, is basically going to execute the job. So our jobs are going to create tables, right? We're going to create a table on the MySQL database. We're going to get the file from the host. So we're going externally, right, to another S3 instance and grabbing that data file. We're going to load that file into the database. Then we're going to check to make sure that the file is loaded, and then we'll send the file back to S3. So one of the things, just to show you this, is that we use the information, some of the information that we got from the variables, right, to run these jobs. These jobs are running on that agent. So this isn't a job that we're running on an agent list that we self-registered, right? So we self-registered the agent, added it to an agent list, and allowed us to dynamically run these jobs without having to install an agent or connect the agent or do any of that work. So now that this is completed, we can see that all the steps are done. Our last step was to actually, I just showed it, was to send this file back to the S3 instance. So after we finish with everything, right, we've already loaded the data. We created the database, loaded the data, captured the data. We've got the file. We've loaded it in, and now we're going to, we sent it back to the S3 instance. So this Kubernetes environment is no longer useful to us, right? So now we want to tear it down. So I'm just going to release, obviously, these jobs would normally be on hold, but I'm going to release this job, and this job is going to remove our Kubernetes instance. So what we're going to see if we go back to our Kubernetes environment is that these things start to go away, right, as we start to tear them down. So just FYI, this pod has 2 images in it, 2 containers, so this usually takes a little time to go away. So we'll just wait here. So this is our, our spin up, spin down example of a Kubernetes environment. And when you need additional processing, we can easily process these work in the local Kubernetes environment, or in this case, this is an AWS instance of Kubernetes, right? We could have run this on Google, or we could have run this on Amazon, or we could have run it on Microsoft. So just wait here. We're tearing down our storage, if we go back here and we take a look, we'll see that we don't have any pods and we don't have any services. And maybe, just maybe, our namespace is gone. So we're back to blank, right? We've completely removed our entire Kubernetes environment. We spun it up, did some processing, then spun it back down. All right, and with that, I will hand it back over to Al.
Thanks, Devin. Okay, so hopefully we can see the power of this, so that we've done our on-prem processing. Devin spun up Kubernetes to actually further analyze all that data, and then he spun the whole lot down and still managed to pass that processed data back to us. So we can do some more tidy up, we can do some more processing here. So let's take a look at what we have. Go back to our business activities, and let's just minimize some of this. Okay, so again, we just put this on hold so we can see how it's going to run through. So we've got couple more steps to go through here. If we highlight this, or maybe we want to do it another way, maybe we want to do something like go up here and have a look with our one of our new features on here, which is to have a look at things through the grouping. So we can have a look within the whole container of this group to see the individual parts down there. Just another view that you might want to use. Of course, the other type of thing that we could do here is have things set up on our dashboards. So there's lots of different ways now to view this additional data. And so we're, you know, whatever way suits, we can handle that as well. So anyway, we can see that. Let's go back to our business activity view, and we'll see that we can now let this one go. Okay, let's switch to PERT again and take a look at what's happening next. So we've got the thing that we need. We're going to do some tidy up stuff now. So we've got the first job to tidy up on the remote machine, on that EC2 instance. So saying here, we're just going to get rid of the stuff that we don't need anymore. We've tidied that away. The next thing that we'll do is to stop that EC2 cloud instance. So again, we've got the status will be reported here. We've stopped it successfully. And if we go to the AWS tab, we can see that that one that we've been using is now stopped. Having done that, we can get our modified data. Now, this is an interesting one because it looks a little bit like just your regular file transfer, but you can see we've done an AS3 get because we've used a data mover job, and the data mover job talks S3, so it gets the right protocol to get that data that's been modified by Devin in the Kubernetes environment and to bring it back to a Linux system there for some regular processing. So we might want to move that around on premise as well. So we've just got another job here to move it around from one place to another, but on premise. And then we're going to update, we're going to reload that database. If we look at the SQL down here, we're just going to do that. We're going to reload the database with the data that's been processed from the Kubernetes side of things. And finally, once we've done all that, we don't need that temporary processing anymore. We want to save costs. So we're going to delete our S3 bucket. And you can see here that the deletion of that bucket is complete. So we're happy with that. We've done our tidy up. So now we can go, if we go back to this view and see the final thing that we're going to do here is to move that compliance data. We want to involve another cloud here. So if we look at number 6 here, we're going to move that compliance data to Azure and report on that. So if we release this one and then switch that one into PERT as well, and we can see this is some fairly simple steps. Once it's found the resources, once the agent's available, we're going to do another copy, just because you can never have too many data to copy. So we're moving it from the Linux system back into the Windows system here. And then we've got another job here And the purpose of this job is to get that data and put it into the blob, put it into the Azure cloud. So this is done with this blob job. And you can see here that once again, we've got the ability to have a number of different types of executions on this thing. So, you know, we can do copies, we can create the new ones, we can set up the metadata, and we've got the just like you can in SQL Server database jobs, we can, you know, combine multiple operations within that one job definition, or we could make them single threaded and have one step per job definition, which is the most visible to the operations staff. So we've done all that. We've you can see from that we've got we should have now in the final flourish that we've got another report from our SQL database, and again we could be sending this out to the management because we've also done the reporting. Sorry, that's one step I should have shown you here, is to go and do our final reporting job, which is to report those audited product lines. So again, all we've done is that we've integrated with one of our existing applications. So we've integrated that with Cognos reporting, and we're going to send the results of that out to whoever might need it via email, whatever method we choose to do it. So the grand result of all this should be that looking at our business activities, going back to this one, let's look at it in that format. I'll collapse everything here, and we'll see that the final, this job is run again to give us another report. And we can see here that the results of the day's processing has been bad news for whoever decided it was a good idea to sell Rip Kane oven gloves, because nobody's buying them. However, the Ken Kachinka autobiography desperately needs restocking because everybody wants it. And a few people fancy a trip around Rick McNeese's vineyard, and why wouldn't you? So that's hopefully given you an inkling of how we can use Tidal everywhere. I'll pass you back to Tom at this point and stop sharing mine. Just share the slideshow again. Okay, Tom.
All right, thanks, Al. So this has been a many-step journey along the way, and it kind of reflects how easy it is to integrate the different systems in different environments into an overall schedule, whether it's on-premise, in the cloud, or a hybrid environment like this one. We've touched on multiple areas where Tidal works on premise. We've touched on Tidal running in AWS and Azure today. It's shown the Linux agent container, which can be spun up and spun down, and also gives you the ability to self-register. You don't have to connect to the agent by configuring it in the master. You simply put the agent in a container and give it guidance on where the master is going to be so it can go and check in. And then, through all of this, what Alan and Devin have shown is that these jobs really don't look that much different than the job types that you're used to. So let's talk about a couple of other use cases that you may want to consider in your use of these tools. Next slide, please, Al. So the there is what we hear from a lot of you is that there is the lift and shift of existing applications from servers to containers. And if you're already using agents to manage those servers and putting them into containers, it's really not a problem. The agents will follow you there. We have the Linux agent today. We have work underway for people who are using Windows containers as well. And likewise, although we didn't call it out explicitly, there's the ability to be able to use Tidal's adapters to connect to, some of the popular targets like, PeopleSoft or a database, just simply by pointing them to the container and giving them the appropriate information. There's really no difference to Tidal as long as there's network connectivity. We don't care whether it's on a server or it's in a container or something in between. You also have the ability to be able to manage resource pools of these containers through Kubernetes. And this is something that, has expanded into a responsibility of many automation teams along the way, not only to be able to run the processes, but also to manage the resources associated, with them. So, making sure that everything works within its SLA, and also that you're using the resources efficiently and shutting down resources that you don't need, along the way. And then lastly, the ability to integrate microservices into new and legacy processes. And calling those microservices is, just one more job definition in an overall schedule. Now, what we haven't talked about today is the ability to be able to run Tidal in containers. And, we've been doing that for a while in our own labs. And this fall, we will be making Helm charts available for those of you who are looking at how you can run Tidal in a containerized environment as part of your shift to move, existing applications, including Tidal, from servers to containers. All right, last slide, please, Al. So I want to kind of close on, the new capability that we're bringing to all of this that Devin has spent some time highlighting is the Tidal adapter for Kubernetes. And, that's really a extension of the capabilities that we've brought to virtual machine management and physical machine management, but it allows you to, work with your Kubernetes teams, whether they're using native Kubernetes or Kubernetes from, one of the cloud vendors or Red Hat's Kubernetes, to be able to integrate that into the existing automation management that you're already doing. That the Kubernetes adapter, makes it simple to go and bring all of those elements in and to work with the development teams who are taking advantage of the ability to use containers to more quickly deploy their applications. And so with that, I'm going to hand it back over to Rick Kane to wrap us up. So Rick?
Excellent. Thank you, Tom, and Al, and Devin. Great job. So before we jump into the Q&A, I just had a few bits of news. So to go along with today's webinar, we'll be offering a special promotion on the adapters that were discussed today, right? So through October 31st, we'll be offering 35% off our AWS, our S3, our Azure Cloud, Azure Blob, Kubernetes, and VMware adapter. So if you're interested, please reach your account manager for more details or receive a quote, or sales@tidalsoftware.com to learn more. Next slide, Al. I wanted to announce early access to one of our upcoming adapters. So due to be released in the next month is our Oracle ERP Cloud adapter, and we're looking for customers interested in early access to begin using it, providing us feedback, etc. So if you're interested, if you've got Oracle Cloud ERP now, or if it's in your future plans, please reach out to your account manager, or you can reach out to me directly at rick.kane@tidalsoftware.com. Let us know, and we'll get you signed up for the early access. So we've been hosting a number of virtual user groups all year. We've got another one scheduled in a couple weeks. It's on October 5th for our Canadian clients. If you're interested in more info on that or in signing up, once again, please reach out to your account manager, and they can get you signed up or get you more information on the event. And then lastly, I just wanted to let everyone know to save the date for our next webinar. It's going to be scheduled for November 18th, and in that webinar, Tom O'Rourke will take us through the 2021 fall launch, discussing all the features, functionalities, new adapters, et cetera, that are going to be in that release. So more details on that to follow, but I just kind of wanted to give you a save the date. And with that, we can turn it over to the Q&A. And we do not have a lot of questions. I'm surprised. I assume that people would be asking where they could get the Rick Kane oven gloves, but no questions about that. And I don't see any questions either on, we did record the session. There was a question about that. But other than that, I don't see anything on the presentation today. So I don't know if anybody's got anything, questions that they want to ask. I'll wait a minute or two here. Here's one. How does the authentication take place from the Tidal to Kubernetes? Is it configured at the Linux agent container? Anyone want to take that?
I can take that question a bit. So I'm assuming that you were referring to our adapter connection. The authentication is configured. It's a combination, right? We'll store some CA information in our adapter connection. And then we'll use, there's a various different types of methods of making the connection, right? We can use tokens, we can use client keys. For AWS, we have, you know, typical secrets. So, and for Google, we also use a similar secret scenario. When it comes to the self-registering agent, it's more typical agent master communication, right? All that stuff is encrypted. The connection is encrypted. The only difference is the master doesn't initiate the connection. The agent initiates the connection, talking back to the master. So hopefully that answers the question.
Excellent. Thank you, Devin. There's a question about the slides. We will make this presentation available on the portal next week for that question. Tom, there's a question about Spring Batch adapter. If you've heard any, I have not personally, but I don't know if you've had any demand or requests for that one.
No, I'll have to go and check, but I'm not aware of other requests for it. So, you know, by noting it here, we'll put it in the list and we'll start taking a look at it. For other people who are on the call right now, if you know you're also interested in Spring Batch, then you know reach out to me at product@tidalsoftware.com, or reach out to your account manager, or talk to Ken and his team via the TSC, and we'll definitely take a look at it. We do have quite a bit in the plans for next year to continue to extend out what we're doing in the cloud and with some of these more modern tools. I'll also say that we're not leaving the the other core elements behind. It's we have demand across the entire environment, and we're going to try to satisfy as much of that next year as we can.
Tom, another question probably for you. Is there what do we have for existing or planned documentation on running Tidal in the cloud?
I probably need more detail on that on that question. For Tidal itself, it doesn't really make a difference whether you're installing it on a physical server, a virtual machine, or in the cloud. And as I said earlier, we're going to provide Helm charts to start providing guidance on how you can containerize Tidal and run it, which is based on our experience. I'll say that the area that we're exploring, and we need to figure out how to share our learnings, is how does the hybrid environment, a mix of on-premise and the cloud, affect the networking decisions that you're making? Because at the root, the major thing that Tidal needs in order to do everything that it's got is network connectivity to all the targets, be they in your data center or somebody else's data center, or just accessible by an IP address out on the internet. So, but we don't have anything specifically there. And, you know, for the requester, if you've got some more specific questions, again, reach out on, you know, on product at tidalsoftware.com, or open a case with the TSC, and we'll try to help answer anything that you've got and figure out how that should shape the documentation we provide.
Excellent. Thank you, Tom. And that is all the questions that we have. I'll give a minute here if anybody's got anything else that they want to ask before we wrap. Otherwise, thank you all very much for joining today. Thanks again for Al and Devin for putting this presentation together. Excellent job, guys. Oh, wait, I might have another one. Let's see. Hold on, sorry. Is there any way we can import a bunch of jobs in Tidal simultaneously? However, I do see an option to export the jobs. I don't know if I'm reading that properly.
Yeah, so this is Ken. So with the Tidal repository tool, you do have the ability to not only export the jobs, which when you do an export, that puts the objects out to a zip file, and that zip file contains a bunch of JSON files with the data for the jobs, calendars, and et cetera. But you can also import that data. So if you're exporting it and you have an environment that's air-gapped or whatever, you can, you know, put that zip file on a USB, go over to your other network or the air-gap area, plug it in, and then import the jobs there as well.
Excellent. Thank you, Ken.
Mm-hmm.
All right. So it looks like that is it. So once again, thank you all very much for joining. Have a great day, and we will talk with you all soon.
Thanks, everyone. Great job, Devin. Great job, Alistair.
Thanks, guys. Look forward to working with you guys in the future.